Welcome to the fastest way to learn data structures and algorithms. Today, we are mastering one of the most famous hard problems on LeetCode, number 124. Binary tree maximum path sum. This is a classic interview question that tests your deep understanding of recursion. Let's look at the problem statement. We are given a binary tree. A path is a sequence of nodes where each adjacent pair has an edge. In this problem, a path can start and end at any node, and it does not have to pass through the root. Our goal is to find the maximum possible sum of all node values along any such path. Think of it like being a gold mine trail optimizer. Each cave is a node, and your goal is to find the most profitable continuous trail. Every cave you visit has two important roles. First, it calculates a peak path, combining its own gold with the best trails from both its left and right children. This is the best trail that ends at this cave as its highest point. Second, it calculates a branch gain, which is the best single trail it can offer to its parent. Because a path cannot branch out in two directions from the same node, a cave can only pass its single best branch up the mountain. For our strategy, we will use a recursive DFS approach. For every node, we calculate the maximum gain it can provide to its parent. Crucially, if a subtree provides a negative gain, we just ignore it and take 0, because we don't want to carry traps into our trail. While we do this, we constantly update a global maximum with the peak path at each node. Let's dive into the dry run. Look at the screen. We have our tree with root -10 and children 9 and 20. At the bottom, we will track our current peak path calculation and our global maximum sum. We start our DFS from the root, -10. It waits for its children to report their best branches. First, we visit 9. Since 9 is a leaf, its children return 0. Its own branch gain is 9 plus 0, which is 9. It also checks its peak, which is just itself. We update our global max to 9. Now we move to the right child of the root, 20. It also waits for its children. 20's left child is 15. It is a leaf, so its branch gain is 15, and our global max becomes 15. 20's right child is 7. Its gain is 7, but it doesn't beat our current maximum of 15. Now, look closely at 20. It has a left branch of 15 and a right branch of 7. By combining both through itself, we create a peak path of 15 plus 20 plus 7, which equals 42. This is our new global max. When 20 reports back to its parent, -10, it can only provide one branch. It picks the best one, 20 plus 15, or 35, and sends that up. Finally, we check the peak at the root. 9 plus -10 plus 35 equals 34. Since 42 is still higher, our final answer remains 42. Now, let's look at the Python code. We initialize maxsum with -infinity. Our helper function, gain, calculates the best contribution from each subtree. We use the max function with 0 to prune negative paths, effectively cutting off unprofitable branches. We update our global max sum at every node by adding the node's value to both the left and right gains. Finally, we return the node's value plus the best single branch to the caller. Looking at the complexity, the time complexity is O of n, where n is the number of nodes, because we visit each node once. The space complexity is O of h, where h is the height of the tree, due to the recursion stack. And that is binary tree maximum path sum, mastered. Save this video for your next technical interview, and follow Leo Academy for more premium DSA guides.